The simulation hypothesis proposes a captivating idea which suggests that our reality might not be as real as we perceive it to be, but could instead be a computer simulation. This concept taps into an ancient philosophical question concerning the nature of reality, which has now been reframed in the modern context using the language and ideas of computer science and technology. With the rapid advancements in technology, especially in the fields of artificial intelligence and virtual reality, this hypothesis has gained substantial traction and discussion in both scientific and philosophical communities. One of the significant proponents of the simulation hypothesis is tech entrepreneur Elon Musk, who argues that given the exponential growth of technology, it's highly likely that we might be living in a simulated reality. He bases his argument on a few key points. First, he points to the age of the universe, which is approximately 13.8 billion years old, contrasted with human civilization, which has been around for just about 10,000 years. Despite this brief period, humanity has already made significant strides in technological advancement. For instance, around 4 decades ago, the pinnacle of gaming technology was the game Pong, which had simple 2D graphics. Fast forward to the present, we now have photorealistic 3D graphics in video games, with millions of people interacting in real time in these virtual environments. This rapid pace of development suggests that we are on a trajectory towards creating highly immersive simulations that are indistinguishable from reality. Even with a modest rate of technological improvement, say a 1% improvement per year, it's posited that at some point in the future, maybe 100 or 1,000 years from now, we will reach a point where the simulations are so realistic that they are indistinguishable from reality. Furthermore, if such a level of technological capability is achieved, it's likely that not just one but many simulations would be created. This proliferation of simulations would result in a scenario where simulated realities outnumber the one base reality, making it statistically more likely for us to be living in a simulation rather than the base reality. This idea is not only confined to mere speculations, but has also been explored in popular culture. Movies like The Matrix and The 13th Floor delve into these themes, entertaining the idea of a simulated reality crafted by highly advanced supercomputers capable of interfacing with human consciousness. Such a simulation would be so realistic and immersive that individuals living within it would be unable to distinguish the simulation from the real world. The simulation hypothesis also intersects with other discussions in physics and computing. For instance, it offers a speculative explanation to some of the strange and counterintuitive phenomena observed in quantum mechanics, such as the state of superposition, where particles exist in multiple states at once until observed. The idea is that a simulation might only render specific details when they are observed to save computational resources, much like how video games today only render the graphics within the player's field of view to maintain performance. In conclusion, the simulation hypothesis, bolstered by the rapid technological advancements, provides a modern lens through which age-old philosophical questions regarding the nature of reality can be explored. It challenges our understanding of reality and pushes the boundaries of what's conceivable, prompting discussions that traverse the domains of science, philosophy, and even spirituality. Whether or not the hypothesis holds any truth, it certainly ignites the imagination and opens up a realm of possibilities concerning our understanding of reality and our place within it. The intersection of quantum physics and simulation theory presents a riveting intellectual venture that seeks to explore the profound and often perplexing nature of our reality. Quantum physics, with its foundation in understanding the behavior of matter and energy at its most fundamental levels, often reveals phenomena that challenge conventional wisdom and classical physics. On the other hand, simulation theory, also known as the simulation hypothesis, posits that our reality might not be as real as we perceive it to be, but could be a highly advanced computer simulation. One of the intriguing overlaps between quantum physics and simulation theory is the concept of superposition, a fundamental principle in quantum mechanics. Superposition posits that particles can exist in multiple states at once, and it's not until these particles are observed that they choose a specific state. This principle was famously illustrated through Schrödinger's cat thought experiment, which suggested that a cat in a sealed box with a radioactive atom could be both alive and dead at the same time, with its actual state only being determined upon observation. Simulation theory provides a speculative yet imaginative explanation for such quantum oddities. It suggests that, akin to a video game, the simulation only renders specific details when they are observed to conserve computational resources. This idea is known as optimization, a common practice in modern-day computing and gaming, where only the elements within the observer's immediate environment are rendered in detail. In this framework, the act of observation in the quantum realm forces the simulation to choose a state for the quantum particles, analogous to rendering graphics in a video game based on a player's actions or observations. Moreover, quantum entanglement, another strange quantum phenomenon where particles become correlated in such a way that the state of one instantaneously influences the state of the others regardless of the distance separating them, could also be viewed through the lens of simulation theory. This could be interpreted as a form of computational efficiency, where the simulation maintains consistency in the behavior of entangled particles to adhere to the underlying programming rules of the simulated universe. Simulation theory also offers an explanation for why the universe seems to follow mathematical principles so rigorously, a feature that's at the heart of quantum mechanics. The digital nature of a simulation, governed by code and algorithms, could provide a foundation for the mathematical regularities and quantization observed in the quantum realm. The dialogue between quantum physics and simulation theory isn't just a fanciful venture, but has been entertained by some reputable physicists and thinkers. It provides a modern narrative to engage with age-old philosophical and existential questions about the nature of reality, consciousness, and the cosmos. The technological advancements, especially in quantum computing and virtual reality, further fuel the discourse, blurring the lines between the quantum world, simulated realities, and the nature of existence itself. In essence, the convergence of quantum physics and simulation theory opens a realm of exploration that challenges conventional paradigms and invites us to reconsider the fabric of reality. Whether these theories provide real insights into the nature of existence or merely serve as intellectual provocations, they undeniably enrich the discourse on understanding the profound mysteries of the universe and our place within it. The simulation hypothesis posits that our reality might be a meticulously crafted computer simulation, a notion that has gained traction within both scientific and philosophical circles. The hypothesis draws upon various facets of reality that exhibit a degree of mathematical consistency and predictability, akin to the programmed environments found in sophisticated computer simulations. One of the compelling aspects of reality that lends credence to the simulation hypothesis is the profound mathematical order underlying the physical world. The laws of physics, which govern the behavior of everything from galaxies to subatomic particles, are expressed through precise mathematical equations. Constants such as the speed of light, gravitational constant, and Planck's constant, among others, provide a rigid framework within which the universe operates. Furthermore, the mathematical consistencies extend to the inherent quantization of the physical realm, as showcased by quantum mechanics. The discrete energy levels of atoms, the quantized spin of particles, and the probabilistic nature of quantum phenomena exhibit a degree of digitalness, a feature reminiscent of computer code and algorithms. The idea that the universe operates on a set of fixed mathematical principles also parallels the functioning of a computer simulation, where every action and reaction is governed by a predetermined set of rules encoded by programmers. This notion is further exemplified by the emergence of cellular automata and digital physics, fields that explore the computational and algorithmic aspects of the natural world. Moreover, the advancement of computational technologies has enabled the creation of increasingly realistic simulations. These virtual environments adhere to programmed laws and constants to mimic real-world physics, showcasing how a simulated reality governed by mathematical principles could feasibly be constructed. It's a small leap from this realization to the conjecture that our own reality could similarly be the output of a highly advanced computational system, adhering to a set of programmed mathematical laws. The numerical patterns and regularities that permeate the cosmos might hint at a form of underlying code, a signature of a simulated reality. This perspective has even led to examinations of cosmic phenomena and fundamental physics for signs of artificiality or computational hallmarks. The simulation hypothesis also engages with ancient philosophical inquiries into the nature of reality and the potential existence of a grand designer or programmer. It serves as a modern iteration of age-old debates, now enriched by the language and concepts of computer science and mathematics. The dialogue surrounding mathematical consistencies and the simulation hypothesis opens a speculative yet fascinating avenue for exploring the essence of reality. It beckons a re-examination of the universe's mathematical fabric, potentially offering a novel lens through which to unravel the enigmatic nature of existence and the cosmos. The interplay between ancient philosophical ideas and modern simulation theory is an intriguing convergence of age-old human inquiry with contemporary technological advancements. At the core of this discussion is the perennial quest to understand the nature of reality, a quest that has evolved with the advent of computer technology and the formulation of the simulation hypothesis. The simulation hypothesis posits that our reality could be a computer simulation orchestrated by a highly advanced civilization or entity. This proposition, though modern, echoes ancient philosophical inquiries into the nature of existence, reality, and the cosmos. The ancients, through their philosophical and metaphysical explorations, often sought to unravel the underlying structure of the universe, much like how proponents of the simulation hypothesis seek to discern the code underpinning our simulated reality. One notable parallel is the Platonic notion of the world of forms, where Plato posited a realm of idealized forms or archetypes as the true reality, with our physical world being but a shadowy reflection of this higher realm. This ancient idea resonates with the simulation theory, where our reality is a constructed facade, with a more profound reality existing beyond the computational veil. The ancient philosophical idea of determinism, which suggests that all events are predetermined and thus inevitable, shares a thematic kinship with the simulation hypothesis. In a simulated reality, every event could be pre-programmed or subject to the immutable laws of the simulation's code, echoing deterministic principles. Furthermore, ancient numerology and the veneration of geometric and mathematical principles in understanding the cosmos find a modern counterpart in the mathematical consistencies observed in the simulation hypothesis. The ancients' reverence for numerical harmony and geometric perfection mirrors the precise mathematical and algorithmic underpinnings that would characterize a simulated reality. In addition, the ancient philosophical discussions around the notion of a grand designer or a prime mover find a modern echo in the speculation around a highly advanced programmer or civilization orchestrating our simulated reality. The simulation hypothesis also offers a platform to revisit and recontextualize ancient ideas of reincarnation, eternal souls, and other metaphysical concepts within a modern technological framework. For instance, concepts of life, death, and rebirth may acquire new interpretations when viewed through the lens of a simulated reality with potentially reprogrammable entities. Moreover, the simulation hypothesis revitalizes the age-old dialectic on the human capacity for knowledge and the limits of our understanding, themes central to ancient philosophical discourse. It challenges us to confront the potentially illusory nature of our perceived reality, urging a modern re-examination of ancient inquiries into the mysteries of existence. In conclusion, the dialogue between ancient philosophical ideas and modern simulation theory represents a rich and multidimensional exploration of existential themes. This convergence invites a deeper contemplation on the enduring human endeavor to fathom the enigmatic fabric of reality, bridging the temporal gap between ancient wisdom and modern technological insight. The concept of the soul, a fundamental aspect of various philosophical, religious, and cultural discourses, finds a fresh yet complex dimension within the framework of the simulation hypothesis. The simulation hypothesis posits that our reality might be a digital construct orchestrated by a highly advanced civilization or a superintelligent entity. This modern theory intertwines with the age-old quest to understand the essence of consciousness, individual existence, and the enigmatic notion of the soul. In a simulated reality, the concept of a soul could be re-envisioned as a form of complex code or a unique digital signature that embodies an individual's identity, consciousness, and perhaps continues to exist within the computational framework even after the physical cessation of that individual. This idea brings forth a modern, digital reimagining of the soul's immortality, akin to traditional beliefs in the soul's eternal nature. Moreover, the simulation hypothesis might offer an intriguing explanation for phenomena traditionally tied to the soul's supposed transcendental nature, such as near-death experiences or certain paranormal occurrences. These could be interpreted as glitches, overlaps, or intentional features within the simulation's code, giving a technologically grounded perspective to experiences often deemed supernatural. In a simulated universe, discussions around the soul also venture into the realm of digital ethics and the philosophical implications of creating simulated beings with a form of consciousness. If a simulation achieves a level of sophistication where simulated entities possess self-awareness, emotions, and a sense of individuality, does this constitute the emergence of a digital soul? And if so, what ethical obligations do the creators of the simulation bear towards these entities? Furthermore, the simulation hypothesis brings forth the notion of a higher reality beyond the digital veil, potentially orchestrated by entities with a profound understanding of consciousness and existence. This idea resonates with many spiritual and religious traditions that posit a higher realm of existence and a divine creator. The interplay between the simulation hypothesis and the concept of the soul also extends to discussions around reincarnation and the afterlife. In a simulated reality, notions of life, death, and rebirth could be reinterpreted as transitions between different states of digital existence, perhaps under the governance of a set of predefined or dynamically evolving algorithms. Moreover, the possibility of uploading human consciousness into a simulation, a theme explored in science fiction and increasingly in serious technological and philosophical discourse, further blurs the line between the traditional notion of the soul and a digital consciousness. In conclusion, the simulation hypothesis offers a fertile ground for re-exploring, redefining, and expanding the concept of the soul within a digital and computational paradigm. It challenges traditional narratives while opening up a vast horizon of existential and ethical inquiries, reflecting the ever-evolving human endeavor to unravel the mysteries of existence and the essence of the soul in the face of advancing technology.